Here's problem 930. Masses are distributed in the xy plane as follows: 6 kilograms at 0, 0, 4 kilograms at 2, 0 meters, and 5 kilograms at 2, 3 meters. What is the x-coordinate of the center of gravity of this system of masses? Okay, let's take a look at this. Let's graph this if we can. We have three masses to consider. We have one at x equals 0, y equals 0. Let's call that mass 1, and that is 6 kilograms. We have another mass at x equals 2, y equals 0. Let's call that mass 2, 4 kilograms. And we have another one at x equals 2, y equals 3. Let's call that mass 3. And that happens to be 5 kilograms. So here's the way our system looks, and we want to find the x-coordinate of the center of gravity. The center of gravity is the same as the center of mass as long as gravity is consistent over our whole system, and that's the only time that it'd be the same, and usually gravity is consistent, but there would be possibilities where you could be in a gravitational field and it's not constant, but we're not going to worry about that. So we'll think of gravity, center of gravity and center of mass as being the same thing. So we want to find the x center of mass, which is going to be the summation of all the masses multiplied by, if I can get this right, their positions over the total mass of the system. So that's going to be mass 1, position 1, plus mass 2, position 2, all x positions, plus mass 3, position 3, all over the total mass of the system, mass 1 plus mass 2 plus mass 3. As we have it here, our mass 1 is 6 kilograms, located at x equals 0, only looking at the x-coordinates, plus mass 2, which is 4 kilograms, located at x equal 2, plus mass 3, which is 5 kilograms, located at x equal 2, all over the total mass of the system, 6 plus 4 plus 5. So this is equal to 0, 8 plus 10 over 15. So that is 18 fifteenths. And that is going to be 1.2 meters. So that is the location of the x center of mass, or center of gravity, 1.2 meters. Just for fun, let's calculate the y center of mass. Y center of mass would be equal to mass 1 times its y position plus mass 2 times its y position plus mass 3 times its y position, all over the total mass of the system. And that would be equal to 6 times y position of 0 plus 4 times 0 plus 5 times 3, all over 6 plus 4 plus 5. So that would be equal to 15 divided by 15, which would be 1 meter. Kind of makes sense because I've got 5 kilograms up at y equals 3, and I've got 10 kilograms at y equals 0. So our y center of mass is closer to the 10, twice as far away from the 5 as it is close to the 10. Our x center of mass is located at 1.2. So where these two lines intersect is indeed our center of mass for this system, located right there. So x equal to 1.2 meters is the x location of the center of mass.